Have you ever wondered what would happen if we could break the ultimate speed limit of the universe? Not by brute force, but by literally sculpting space-time itself? Today, I'm diving into the mind-bending world of negative effective mass. And micron-sized warp bubbles, a cocktail of quantum physics and cosmic engineering that could, one day, let us ride a wave right through the fabric of reality. Let's start with negative effective mass. Imagine pushing an object and instead of moving away from you, it zips right toward you. It sounds impossible, but in the quantum world, some materials can behave as if they have negative mass. Combine that with the concept of a warp bubble. Contracts in front of a ship expands behind it and suddenly you're not moving through space. Space is moving around you. Now picture this, a third-generation quantum propulsion system, one that doesn't just move through the void but flows with it. The core of this system uses a micron-sized warp bubble generated by a supercooled field that rides on what I call a cold wave. A kind of quantum wake that propels the ship, cools it, and recycles thermal energy as usable quantum fuel. Here's how it works. First, warp bubble guidance. The ship rides the cold wave like a maglev train, steering through space-time with surgical precision. Second, thermal inversion shielding. As the ship speeds up, it expels heat outward, keeping the inside cold and stable, perfect for those delicate quantum states that make all this possible. Third, quantum buoyancy. Imagine levitating, not with engines or thrusters, but by floating on a pure field of manipulated space. And finally, entropy recycling. Nothing is wasted. Every bit of heat, every quantum fluctuation gets fed back into the system as fuel. Nearly perpetual motion, at least in theory. But here's the real kicker, the infinity radiance. As the ship rides its cold wave, it generates a glowing, shimmering aurora. A radiant display of quantum coherence, lighting up the darkness of space like a supercooled rainbow. It's not just fast, it's beautiful. So, what would it be like to ride this wave? You wouldn't feel acceleration, no crushing g-forces, just a sensation of gliding, pivoting and flowing, motion as elegant as a brushstroke on the canvas of space-time. It's not science fiction, it's the next great leap, motion, not as a battle against physics but as a partnership with the universe itself. Who knows? One day we might not just travel through space, we might learn to dance with it.